Hey everyone, yeah, thanks for joining. I'll talk about a bit, as Serena already introduced, about notebook internals in Theia. I will take us in a deep dive, let's say. We will take a look at a few architectural and technical challenges on how to implement such a feature in Theia. First off, I'm Mark. Some of you may have seen me in the GitHub repository quite often. I'm often answering questions and issues about Theia. I'm a project lead of the Theia project. I work at Typefox. I do a bit of lecturing on the side at Hamburg University, and I'm generally involved in a lot of open source stuff. For example, the Langium open source Eclipse project as well. But today we'll be talking about Theia and notebooks in particular. So first off, let me explain what notebooks actually are for those who don't know yet, and then how they've kind of evolved in the IDE space with initial IDE integrations and then going on into native IDE integrations, which is what we've done in Theia, and then some of the technical challenges that we've been encountering while doing so. So first off, notebooks themselves kind of started as an idea back in 2001, where the Interactive Python project was started, short for IPython. It was simply a way to execute Python code snippets in your terminal and return it as multimedia output. So you don't get just a console output or something, but you can generate a plot or something that's much more visually appealing and interesting for yourself, because oftentimes just some console output probably isn't enough in order to take a look at thousands of lines of data or something like that. And that was back in 2001, and that kind of evolved later on into Python notebooks, which released in 2011. And so it kind of took the main ideas and features from IPython, meaning the execution, the impromptu execution of code, and the presentation of like multimedia, HTML, interactive output, but embedded it as a web app, and also gave it documentation alongside to the code. So as you can see in here, for example, I don't know whether you can actually see it. There's rich text in addition to the code, meaning that you can always explain what's going on. You even get like markdown extensions for it. So in general, the documentation, I believe, was used as markdown, and then you could write mathematical formulas in there and so on. So just give it a lot more context, a lot more information, and then you could run the code, get immediate output, and can quickly iterate over ideas and so on. That was quite nice, but it had a few issues, especially when it came to interoperability between Python, or rather other languages, because obviously Python notebooks was fairly limited to just Python. And so a different kind of project actually spun off from Python notebooks, which was eventually became known as Jupyter notebooks. And so they split off in 2014, and one of the core design or architectural ideas was that Jupyter Notebook isn't actually closely related to Python, but it's actually completely language agnostic. And it uses just IPython as a kernel for executing Python code, but it's nothing that's limited to Python exclusively. So you could run R, for example, or MATLAB, or whatever kind of data analytics language or engine you want to run, or maybe you could even run, I don't know, Visual Basic, C# bash code in there. And Jupyter Notebook became hugely popular, especially in the whole research and data analytics space, because it was simply a simple way to share data and operations on data together with all of the code and together with all of the documentation and ideas, etc., surrounding that. And was quite nice. And I believe there are now more than 10 million Python Jupyter notebooks on GitHub alone. I believe the number has been increasing quite a lot in the recent years. So it's immensely popular. And so the question has become, well, if it's code for the most part, why not run it in the IDE? And that's the question the VS Code team at Microsoft has tried to answer back in 2019, when they've tried integrating Jupyter Notebooks into VS Code. So they've started off with a VS Code extension that simply uses the VS Code WebView IDE, WebView API, in order to display a notebook-like WebView HTML document. And this has quite a few advantages, actually, because since it used simply the WebView API as it was, it ran in Theia out of the box. And that was fairly nice for all Theia adopters who wanted to do something with Jupyter Notebooks in particular, because it simply ran out of the box. No complicated setup necessary. Perhaps you needed to install some kind of Python kernel or something, but it was easy to use. However, it came with its own kind of disadvantages, or issues at least. For one being that that was fairly complicated to extend the ideas that made partly Jupyter Notebooks so popular, which is that it was language agnostic, and adapted to the Jupyter Notebook extension that was released back in 2019, because it was kind of fairly limited to Python, at least when it came to language support. And one of the issues was also that it was fairly slow, because it had to embed Monaco, everything itself in there, and all the communication had to go through multiple layers of VS Code extensions and so on. At least when I tried it back in 2020, it was still fairly slow. And so this can be seen as kind of a POC from the Microsoft team, because eventually this became the native notebook API in 2021. And that was quite nice, because it really took over the ideas that made Jupyter Notebook quite popular as well, because it also became language agnostic, and you could also simply register custom kernels, for example, and do all of that through the VS Code API. And that was nice for VS Code. It was nice for VS Code users. And it was also fairly nice for extension developers who could easily write custom kernels. We did so back in 2022. We have a blog post about that, where we write a custom DSL, like a custom programming language, and actually add a custom kernel for it for notebooks. That was actually really cool. However, but when it came to Theia, this becomes quite a problem, actually, because it's not longer based on the WebView API. It has a completely new front end. It exports or exposes completely new and additional VS Code API, which essentially means for Theia that we need to do a lot of work to implement it. And that's what we eventually did. So more than a year later, we started working on that. And more than like 1.5, 2 years later, it's actually kind of finished. We're quite happy with the state of it. So let's dive into the actual implementation of how we did this. So one of the main, let's say, arguments that we can, or main paths that we can look at, is the general communication that's going on between the front end and the back end, which really explains how the feature is working in general. So from a user perspective, all you really see is just the notebook editor as some kind of widget. I will later show how it looks like, actually. And you've seen it in VS Code. It looks very similar in Theia, actually. And then on the back end, you install some kind of kernel process, usually some Python package on your machine, and that's kind of it. Now the question becomes, how does the notebook editor actually communicate with that Python kernel? And for that, the VS Code team has decided to use, obviously, the extension host system, so the plugin API, and we're doing kind of the same, right? We offer the same API as VS Code, so we have decided to also offer the same API when it comes to notebooks. And while we have a small abstraction layer between the plugin host and the notebook API itself, most of the notebooks themselves are simply or notebook features are simply contributed throughout the plugin host. And so what we have in Theia is that we just have a simple kernel service available that the notebook editor can use to, for example, get all the metadata information about what kernels actually registered. So what the plugin host can do is that it simply, once a VS Code extension wants to register a kernel, it will simply send a notification to the kernel service, which makes all of the metadata available for Theia to use in the front end. And so obviously the plugin host or the plugin itself then needs to implement the communication between the notebook kernel and the plugin kernel that it implements. But really, that's up to the extension developer or plugin developer. We, as developers of Theia, don't really need to care about that, how it's actually done. And so once the kernel is registered, we can simply execute it from the front end. So we just send a message to the backend, to the plugin host, essentially saying this kind of code cell needs to be executed. And we simply get a result back. So we have this kind of back and forth between kernel service and plugin kernel that's living in the backend. And we display all of this information as part of an output that is rendered inside of the notebook editor. And so in our notebook editor itself, we have all of these small code cells that we want to display as well. And as a kind of last big feature that I want to present here, these code cells also should have actual code support, right? If I click on a reference or something, I want to jump to that reference within the code cell. If I mistype something, I want to get an actual error diagnostic that something isn't available. I want to get syntax highlighting, code completion, all of that jazz. And for that, we actually have all of the text editors, all of these code cells available as individual text editors, which are actually replicated to the backend, to the plugin host, in order to give all of the, let's say, language smartness back to the notebook editor that is already available in our default Monaco editor language services. So all of the Monaco editors in Theia are powered by the same engine that also power now the notebook cells. And so we don't need to do actually a lot of work except for replicating all of the notebook editors, so the small cells within the notebook editor, back to the plugin host, and then retrieve all the language service information that we get from there. And so this is kind of a small overview, and it doesn't look like much, but this has been months of work, in fact. I believe in total, like the few initial PRs that have contributed to the feature were 25,000 lines in total. Quite a lot. It took us multiple months to get this to work, but eventually it was working kind of. And that's actually the next part I want to talk about, which is the technical challenges that we encountered, which are mostly performance issues. So you can imagine that a lot of people that work with notebooks don't only write like toy examples with them, right? They do huge tutorials or something. They essentially write whole papers or theses into those notebook documents. And so they have hundreds of, even thousands of code cells, hundreds of documentation cells. And usually each code cell comes with its own output. And so what's happening is that when you open a notebook document, is that you essentially need to load hundreds of code cells and whatever. And so what we did initially is that we just, happily went along with those hundreds of code cells and initialized hundreds of Monaco editors. And as you can imagine, this probably brings down the performance quite a lot. In fact, it essentially made the application come to a stop for multiple seconds oftentimes. This was luckily an easy fix, obviously. We just started lazily rendering those Monaco editors. So once they came into view, they were kind of activated and became Monaco editors. Before that, they were just simple text nodes, essentially, in the HTML document. But there were quite a few issues, actually, which weren't as easily solvable. One being, for example, an RPC bottleneck. When we open large notebooks, you see a theme here. Generally, it's not an issue rendering small notebooks. It becomes really an issue if you work with huge notebook documents. And the RPC bottleneck, let me quickly show you a graphic, actually. So like I said, we replicate all of those text editors that are available in a notebook to the plugin host. And so what we did was we sent hundreds of update notifications when the notebook editor was opened in order to replicate each cell individually. And this kind of clogged up the whole RPC mechanism from the front end to the plugin host, where the backend is kind of squeezed in between. And so what eventually happened is, because of these hundreds of thousands of messages that we immediately sent to the backend, we kind of clogged the whole backend front-end communication. And if you had that many documents, the front end actually no longer received any kind of health check information from the backend. And so it just assumed it was offline. This obviously wasn't working. And so what we did is that we started batching those RPC calls, because, well, sending 1,000 messages obviously didn't work. So we're sending 1,000 documents inside of one message, which works much better actually, and wasn't actually any kind of bottleneck anymore afterwards. So that was nice. Learning about that was cruel, but nevertheless interesting. And then there was the issue of rendering a lot of outputs. And that was actually much more difficult to fix than all of the issues before. Then were also, by the way, some browser-specific issues. Some of you may have issues with Safari in the past when it comes to development. These were hugely exaggerated in this case, but let's talk about outputs first. So if you take a look at a simple notebook document, you will find that it's usually a collection of cells interchanged with output information. So in here we have just 3 code cells. Let me mark them actually. So in red, they're just Monaco editors. And then in green, we have all of the output information. And we took quite of a naive view on all of that, because each of those green fields were simply individual iframes, because the rendering of those notebook elements, or notebook outputs rather, wasn't simply done via something like simple HTML elements, because you could actually register custom notebook renderers and then let them do all the work. So you could have really, really complicated interactive HTML data in there. So it didn't just work out to just render a simple HTML table or just some arbitrary simple HTML data. No, it was actually much more involved. And so it didn't really work out to just push the HTML into the notebook editor itself. We actually had to use iframes for them. For one, because the notebooks renderer themselves were arbitrary arbitrary JavaScript that was executed somewhere in the front end. And so it was kind of also a security measure in that sense, because otherwise it could have impacted the general front end as well. However, the issue of using individual iframes was quite obvious. So if you started opening, for example, a notebook with, let's say, 50, 60 output views already loaded from the beginning, you would see them being slowly opened one by one. And that's obviously because the browser engine itself wants to load each individual iframe one by one, and in order to not kind of kill the front end, it just throttles itself. So you could see in real time each iframe being loaded with all of its CSS and JavaScript resources and so on. And that was quite slow, obviously. And you could also see that the front end was noticeably lagging while loading all of these individual iframes. But on the other hand, the naive view was also kind of easy to implement. It was very simple to get it running and working, because it was just HTML elements stacked after another, right? It was just a Monaco editor, an output, Monaco editor, an output, and so on. So it was fairly easy to work with. But as we have seen, this didn't really work out, at least for large documents, because it was just incredibly slow. And so we bit the bullet and searched for another solution. And the other solution was actually quite simple, because most of our problems were the fact that we were loading hundreds of individual iframes. Why don't we just load one single iframe? And so the idea is the so-called backlayer solution. The backlayer solution involves just loading a single iframe and embedding all of the outputs within them. And obviously this becomes quite a bit more complicated, because we now, cannot simply let the browser engine do the DOM layouting by itself. because previously, we just stacked all of the elements right after another, but we just have one element intermixed with all of these Monaco editors that are still living inside of our actual Theia DOM. And so what we need to do now is we actually had a lot of communication back and forth now between this backlayer view and the rendering engine of the notebook editor, because in order to figure out where each output view is supposed to go, we first need to know how high each of the individual editors is now. And so when first layouting the notebook view, we first send all of the height information about each individual editor to the web view. And once that's done, we actually need to do the same, but in reverse. So we now need to lay out all of the outputs. And once we have the height of each individual output, we can set that information back to the original Theia editor or the notebook editor. And then we can actually start layouting everything. And that really needs to be pixel perfect. And as you can imagine, with if you tried doing pixel perfect CSS with web views in between or iframes in between, this can be quite complicated. It took us quite a bit of time to actually get everything pixel perfect, because if you don't, and we've had that happen quite for a while, you will see that outputs suddenly get kind of clipped or maybe even underline or underlie directly in a certain Monaco editor or something. So essentially, not only does it look bad, it oftentimes just leads to missing information in the outputs. And so it took quite a while to get everything up and running and pixel perfect for that. But I believe as of the end of last year or something, we kind of fixed all of the major issues. And so far we have really received just quite a very few new issues since then. So that's quite a success in that regard, because it really was a lot of work in that area. All right. So that's actually it. So these were most of the really big challenges in that regard. Obviously, you can imagine this took a lot of code. It just took a lot of time in general to implement. But yeah, that's most of it, really. Most of the complicated issues and challenges. Yeah, if you have any questions, feel free to write them in chat. Otherwise, thanks everyone for listening in.
Thank you so much, Mark. So we do have one or two questions actually that are coming in here. So let me open this up. All right. So Mark, regarding the performance issues, reach out to the Trace Compass team. I want to help. Let's discuss at the next step. So not a question, but more so a comment. Okay. Thank you, Matthew, for that. All right. So from Michael, well, the idea of notebook is much older. Donald Knuth called it Literate Programming and Mathematics by Stephen Wolfram. Did this in the 80s. Again, not so much a question, but I guess a comment. Do you have anything to say to that?
I mean, yeah, literate programming is quite something. I've worked with LaTeX quite a lot in the past. It's something. But yeah, I mean, the general idea behind like IPython, yeah, it's older, but the Jupyter stuff that's really traceable back comes from back in 2001. So I started with that. But there are ideas that are quite a bit older than that.
Okay. And then another question is, what happens if some pop-up in the background iframe overlays the Monaco editor?
That's a good question, actually. So let me quickly open this previous slide again. Yeah, this one. If the pop-up were to overlay the Monaco editor, so if it were to, let's say, reach into the area of the Monaco editor, it would actually probably be hidden, because from a DOM perspective, the Monaco editor is simply on top of the iframe, just so we prevent other weird rendering issues. And yeah, this would eventually result in the fact that the pop-up would be partially hidden, at least to some degree at least. Although I believe for the most part the renderers themselves try to keep the pop-up size limited to the size of the actual output. So if this actually were to happen, it's like more likely an issue of the renderer and less of our implementation approach.
Great.
But it's a great
Thank
question.
you again, Mark, for the detailed presentation and as well for answering the questions. If there's any questions that are missed, Mark will be able to go in and answer them in the Ask a Questions tab directly.